Welcome to Easy Btech, your guide for Btech and beyond. In the today's topic, we will discuss regarding the Varactor Diode and its applications, and we will discuss regarding the comparison of Bjts and Fets. Okay, students, we will start the session. Varactor Diode. Varactor Diode. The name Varactor stands for variable cap or variable capacitor. Variable capacitor or tuning or voltage variable. Voltage variable tuning or voltage variable capacitor. These are the names of the Varactor diodes. Varactor diodes are widely used in tuning circuits, especially in FM and TV receiver circuits. Next, Varactor diode is operated in reverse bias only. That is, when a PN junction diode is operated in reverse bias, it exhibits variable capacitor behavior. It exhibits variable capacitor behavior. As we know that when diode is operated in reverse bias, it exhibits a capacitance. It exhibits a capacitance across the junction. It exhibits a capacitance across the junction known as transition capacitance. Transition capacitance. Okay, generally during reverse bias operation, diode exhibits a larger resistance, that is hundreds of mega ohms. In reverse bias, diode act as open circuit, and open circuit resistance is larger. Okay, now generally if you see the structure, It is a reverse bias. Now it is a positive. It is a P-type material. It is an N-type material. This is a depletion region. This is a depletion region. This is a depletion region. Either side of the junction, this side is you are having positive ions. This side you are having a negative ions. These are known as immobile ions. Here these two are known as mobile ions. It means movement can be there for the mobile ions. Immobile ions, there is no movement. Okay. During the reverse bias, what happens? As the reverse bias voltage increases, these charges can attracted towards this negative, and this negative attracted towards the positive, and the width of the depletion region increases. Okay, the width of the depletion region increases by increasing the reverse bias voltage. The width of the depletion region decreases by decreasing the reverse bias voltage. It means width expansion is directly proportional to the biasing voltage. Width expansion is directly proportional to the reverse bias voltage. Okay, that we will say as reverse bias voltage increases. As reverse bias voltage increases, the width of the depletion region, the width of the depletion region, the width of the depletion region increases. The width of the depletion region increases. Okay. The width becomes larger. Okay. As reverse bias voltage decreases, the width of the depletion region, the width of the depletion region becomes narrow. Okay. Due to this region, a capacitor a capacitor behavior exhibits across the junction. That is, we know that C is equal to Q by V, or C is equal to dQ by dV. It means a rate of change of charge with respect to the voltage. Rate of change of charge with respect to, that is the behavior of the capacitor. Now, capacitor across the junction is transition capacitance. That is, CT is equal to epsilon A by W, parallel plate capacitor. It means as reverse bias voltage increases, width increases. Width means depletion width increases, but capacitance decreases. Is it clear? Capacitance decreases. And now next, as reverse bias voltage decreases, width decreases. transition capacitance increases. Is it clear? Generally CT varies from 50 picofarad to some 700 picofarad. Pico means 10 power minus 12. 10 power minus 12 we will call as a picofarad. Next, a capacitor. This capacitor across the junction act as a parallel plate capacitor. Parallel plate capacitor separated by a depletion region width, act as a insulator. Okay, P is a positive plate, N is a negative plate. Now it is a P is a positive plate and N is a negative plate, and this is a separation, two plate separation. Now if you see in this diagram, now here it is a P positive plate and it is a negative plate. Both the plates are separated by the depletion region. This act as an insulating. This region can act as an insulator region. Okay, due to this behavior, Varactor diode is used in FM and TV receiver circuits. FM and TV receiver circuits. Next, Varactor diode exhibits a variable capacitor for frequency tuning purpose. Next, Varactor diode is used as LC resonant circuit. Now if you see a graph, now as reverse bias voltage, this is a reverse bias voltage versus CT transition capacitance. This is as reverse bias voltage is 0, transition capacitance is more. As reverse bias voltage increases -1, across the biasing reverse, if voltage is increased, then this capacitance is decreased. Okay, this it is a reverse bias. It is a reverse bias voltage. As reverse bias voltage increases, transition capacitance decreases. CT decreases with reverse bias voltage increases. Okay, students. So this is about a Varactor diode. This is about Varactor diode. If you see a basic comparison of Bjt and Fet, between Bjt and Fet, already we discussed this, but in detail we will study today. Bjt, Fet, means JFET. FETs are of two types, MOSFET and JFET. Bjt stands for bipolar junction transistor. It stands for junction field effect transistor. junction field effect transistor. Next, as it has both the polar, that is why it is a bipolar. Here it has only unipolar. JFET is known as unipolar device. Bipolar device, unipolar device. Next, current conduction. Current conduction in the device is due to both majority and minority carrier. Both majority and minority carrier. Current conduction is due to only majority charge carrier. Majority charge carrier. Only majority charge. Here both minority and majority. Next. Bjt is known as current control device. Current control device. FETs are known as voltage controlled device. Voltage controlled device. Next you can remember input current controls the output current. Input current will controls the output current. Here input voltage controls input voltage controls the output current. Input voltage controls the output current. Next, Bjt is a temperature sensitive. Bjt is a temperature sensitive devices. Means minority current increases with the temperature. Here absence of minority carriers FET is known as independent of temperature. Independent of temperature. Next, Bjt is larger in size. FET is smaller in size. Next, less power consumption. More power consumption. It is a less power consumption. Next, Bjt is heavy in costs. FET is cheaper. Bjt is difficulty in fabrication due to size. FET is easy for fabrication of ICs. Next, Bjt has more gain into bandwidth product. FET has less gain into bandwidth product. It means simple, you can say what is a gain bandwidth means we can draw a frequency responses, amplifier frequency responses. Now we will calculate a gain versus frequency responses of an amplifier. Now this is a maximum gain. After finding a 3 dB gain, we will find out the cutoff frequency. After finding the cutoff frequency above the 70%, we will find the lower and higher cutoff frequency, from which we will calculate the bandwidth. If you multiple the gain into bandwidth, its product is more. Whereas in this case of FET, its gain into bandwidth product is less. Gain into bandwidth product is less. Okay. Okay, students. Easy Btech guide for Btech and Beyond. Thank you.